Hi, my name is Steve Bjork. I'm the author of LambdaSharp and the CTO and founder at MindTouch. Today, we're going to be talking about how to publish and share modules in LambdaSharp. Very important. That's a fundamental capability of the tool that was built in. And so we'll cover a few things, just make sure that we have the foundation about LambdaSharp modules, what they are, how they work. Last time we covered them in quite a bit of depth. Talk about CloudFormation, which is the key service in AWS for deploying and how it interacts with artifacts. Then the active sharing modules, what it looks like and how it works. And then lastly, consideration for CI/CD pipeline, which is a much more sophisticated scenario and should be interesting once you start automating some of these processes. Okay, so to get started, let's take a quick look again what the LambdaSharp module is. Ultimately, the module is a definition of a CloudFormation template and several artifacts that are part of it, which then become either private resources or public resources. We covered that in the last session. In order for these resources to get created, CloudFormation needs to have access to them. And that's where kind of the meat of the work lies. We're going to go in some of the mechanics of it. But before we do, let's take a quick look at a sample module. So this is in the GitHub repo that's going to be shared. So you can repeat the same commands and experiments that I'm doing. You may have to customize some of the parameters because, for example, S3 buckets have globally unique names, so you won't be able to reuse them. But here we have a very simple module. It has a Lambda function called analyze function. It's based again on the Bitcoin theme that I've been using for the last presentation as well. It's a firm foundation to build on simply because there's a Bitcoin API that publishes a price every minute, and so there's always ongoing activity that you can have reactive behavior going off on them. So it's very convenient. It is by no means an endorsement of Bitcoin. Just wanted to be clear. So when we build this module, so I'm already in the right folder, the module YAML is here. It will compile the function code, the .NET project that is attached to it, and it will create the artifacts needed to instantiate it. And these are created inside the bin folder. So if I look in here, there are two artifacts that were generated. One is a zip file that we cannot look at. That is the compressed .NET compressed output of the build folder. And then also a CloudFormation.json. The version that is stored here is pretty printed, so it's easy to inspect and just see what did the tool generate in terms of CloudFormation. But what gets uploaded will be a minified version just for space considerations. And since it's not that necessary to be able to read it over there. So those are the two artifacts that this module generated. But depending on how many functions or apps or other additional packages, which is another command, are in your module, you may have multiple additional artifacts that get generated. And there are 4 types of artifacts that exist. There's the minified CloudFormation template, JSON. Of that, there's only one per module. You can have an arbitrary number of function packages, zip archives, that are being used by the Lambda service to deploy your code. There's also an app declaration, which is a Blazor WebAssembly project that gets zipped and again deployed in S3 bucket in this case. And then there's also a more generic command called package that allows you to zip any folder on disk, and you can also run a custom command before you do so in case it does a build step or so. The command for that is actually called build, so that you can take these build assets or just loose assets, for example, for a website, zip them and make them part of your module that gets uploaded. So those are the 4 types that LambdaSharp supports today. And the last one is quite generic, can be used for Lambda layers, can be used for packaging Alexa skills. A lot of the resources often use a zip archive or something of that sort as their input. So it's quite useful in many situations. So let's talk about what happens next. When you publish, let's say you've set up, you have a deployment tier set up, you're ready to go, you have your module locally with your project files. When you publish, they get uploaded to S3. And then CloudFormation can be initialized to basically create your stack. Now, technically, CloudFormation allows you to also create a stack directly by just providing the JSON directly in the call. You have a smaller size limit. However, in order to make sure that we have everything that we need all the time, LambdaSharp uses the approach of initializing CloudFormation from the template JSON that was uploaded, and then point to the various artifacts that were produced as part of the build phase in order to get Lambda functions and so on and so forth. The various things that can be instantiated. Unfortunately, it's important that the artifacts, specifically the bucket, is created in the region in which you want to deploy. CloudFormation itself does support reading a template from another region. However, the Lambda service, for example, does not. So in general, you just want to make sure that whichever region you're deploying to, you have a bucket that is in that region. It's just a necessity out of the design of Amazon services. Now you have two ways of doing it. One is you publish multiple times. You just, you have different deployment tiers, and you run the publish command from the command line whenever you want to publish to one or the other. That works, but it's not particularly conducive to sharing, right? Because we don't want individuals to have to run the build command and everything. There's no guarantee they would build exactly the same way, which means that it might introduce subtle bugs due to nuances. So a better approach is to copy. And then we know exactly which artifacts they were from the previous region. Hopefully it was working fine in US West 2, and what we get in US East 1 is a bit perfect copy of this artifact. So when we deploy them, we expect the same behavior. Modulo, of course, if we made the mistake of hard coding the region anywhere in our definitions, which hopefully we avoided. The challenge with copy, there's a few. One is, well, which bucket do we copy to? What is it that we need to copy exactly? Do we copy everything from the bucket? How do we organize the contents of the bucket? In particular, if you look at how CloudFormation resources reference assets in S3 buckets, they all split into two. One is the bucket name, and then there's the key for where the asset is in S3. Now, we already know that we want the bucket to be variable, so that's going to have to be parameterized. But it would be best if we could use the paths just as is. We don't have to rewrite them. It gets tedious. And if we did rewrite them, we would have to keep track what do we use for rewriting this particular template when it was imported alongside. So best if we can just keep the key path as is, because then it makes it a lot easier. The challenge then becomes, though, if we're copying from multiple buckets into our destination bucket for deployment, we could have collisions. Basically, somebody called their module the same that we called ours, and now they occupy the same location in the S3 bucket, which would be a problem. So we need to avoid that as well. So fortunately, there's a solution for all of it. Probably the easiest way to explain this is kind of going bottoms up, as opposed to top down, as the problem was explained here. So one thing that is really critical is what needs to be copied. When we looked earlier at the CloudFormation JSON that got generated, I'm going to scroll here to the bottom of it. There is something that's embedded automatically in the metadata section of the CloudFormation template. And that is called the LambdaSharp manifest. And this is a document that specifies a whole bunch of additional metadata around what's part of the module, how it was built, but most importantly, it lists all the artifacts that are part of it. It doesn't list the CloudFormation template itself, because that one can be constructed from the template checksum and the version and so on, as you will see. But it does list all the artifacts that are part of it, with, of course, a checksum and so on and so forth. So that's the module manifest. It exists both in the template and as an independent file, so that the template doesn't have to be downloaded in its entirety, which can be fairly large, when we only need to have the metadata about the template. And that information, kind of going deep in the bucket, is stored in the following structure. So we have some parent folders here which are not shown. I'll show that next. But this is we're looking at the Bitcoin.topic module. So we're looking at the topic part, which is the module name. The Bitcoin prefix is called the module namespace. The manifest file, the manifest JSON file, is stored in this case as 1.0. That is the file name of it. And that is what we do in order to kind of like track what versions are available of a given module. So the tool, when it looks for a specific version that is compatible with what you're trying to build or deploy, will scan the manifest to find something that fits the requirements. In addition, there's a subfolder called .artifacts, which contains all the artifacts of all versions. And the reason this contains all the versions is because if you did not change, for example, how the Lambda function is compiled, then the same artifact can be used and there's no need to duplicate it, which would be wasteful. So the .artifacts contains all the unique artifacts that are needed in order to create the CloudFormation stack. And again, these are tracked by the module manifest. So when the tool finds that you want to copy a given module, it downloads the module manifest of the version that was selected, and then uses it to identify the artifacts that belong to this version. The CloudFormation template is identified by the full module name, which is the namespace and the name of the module itself, plus the checksum. And then similarly for the functions, again, full module name and the name of the function plus a checksum. So that's kind of like deep in the bowels of the S3 the structure. Going a couple of levels higher, actually back to the root, we can see now, this is where we were actually in the topic subfolder. We have a parent folder called just Bitcoin because that's the module namespace. So this is just an organizational arrangement. Everything is organized by that first name. That's why LambdaSharp modules always require a prefix, a dot, and a suffix, which can contain dots itself again, as we will see in another module. But the prefix can, for example, should be your company name or your organization name, something like that. That allows you to then have the nicest side by side. It's more of an organizational for making it a little bit more, the user experience a little bit more approachable when somebody has to go into the S3 bucket as opposed to listing everything flat. Now, the parent folder for the published module has a name that is the name of the bucket from where those artifacts originated from. And that is kind of like the key to avoiding these collisions when copying multiple module artifacts from different buckets. Bucket names are globally unique. They're a little bit like top-level domains. You can't have two buckets called serverless patterns. I have that one, sorry, you can't have it. Which means if we use it as a prefix, always consistently, we know that only artifacts that got imported from the serverless patterns S3 bucket will exist in the subfolder. And so this allows us to make sure that even though we bring everything together, we don't have collisions. We're just safe from it. It doesn't matter if somebody else creates a Bitcoin.topic module, for example, in my bucket, which would be how these names are correlated. This is a bucket I created for maybe my project or my deployment tier. I can have a Bitcoin.topic in here, and it's completely separate from the serverless patterns one. It just provides a stronger identity. So the full name of a module, which is the namespace, the name, the version number, and then the at the end is the origin. That is the name of the bucket that we use for finding these artifacts. And then we use it again, knowing that this is the bucket we found it in, to actually build the subpath. This allows us now to merge buckets safely when we deploy. So this is the same, explain again. We have an origin bucket. This is where our CloudFormation artifacts exist that we published. We want to bring them into our deployment tier bucket. That is eventually where we want to publish to. A deployment tier exists in a certain region. It's the region we want to deploy into. So the problem of which bucket to publish to is implicitly solved. And then there's a very simple rewrite of only the name of the bucket, really. We're copying, we keep the origin name, we keep the namespace, we keep the name and any artifacts that are underneath, and they all get brought in from the deployment, into the deployment tier bucket from any number of origins that are needed. So that's kind of the process by which this works. Okay, so now this answers the question of how do we make these artifacts available for deployment in our region. We haven't said anything about sharing them with the world. And there's a couple of additional steps, again, to make it a little easier, but a lot of this can actually be done through other means rather than using the LambdaSharp tool itself. The first one is if you wanted to share it, with the world, you can create a public bucket. And that's the easiest one. If you want to share it just with another account, that's where you should probably either write your own CloudFormation template for it, or go in the console, create a private bucket, and then provide the appropriate role for the other account to access it. You have full control over the bucket that you associate with the deployment tier. The LambdaSharp tool will create a bucket by default, and they used to have somewhat cryptic names because they're dynamically created and have to be globally unique. But there's absolutely no reason that you cannot provide your own, which is exactly what is supported and is key to this sharing mechanism. So in this case, I ran the lash new public bucket command, which then had the tool prompt me what name I wanted to give to the bucket. In this case, this one was not taken, otherwise it would have failed. It creates a stack, so it's easy to see which buckets have been created, because again, CloudFormation is kind of like our go-to place for seeing anything that has been deployed. We are not big fans, or I'm not a big fan of having things being created and CloudFormation doesn't keep track of it. So there's a stack that points to the public bucket. And most importantly, because CloudFormation doesn't support it as part of their definition language, it does an additional API call to enable this requester pays access feature. So this was created fairly early on in the lifecycle of S3. And I think we just celebrated the, was it 15 years of S3? So it's one of the oldest services, and certainly one of the most popular that AWS has launched, especially now that they've reached, I believe, 100 trillion blobs objects stored in S3. That's just an inconceivable number. But here's something that they did that's just brilliant. Because they wanted individuals or organizations to use S3 buckets to share data sets with each other. However, they didn't want the person who makes the data set available to be on the hook for paying access to it. And that would also be potential concern of yours. If you share a module and it's getting popular and it's getting fetched a lot, it's your bucket that's tied to your account, it is tied to your credit card. So that's not, that can be anxiety inducing potentially. However, unlikely that might be the case. However, with requester pays, it is actually not you who pay for the data transfer. You still pay for the storage, but it is the person who requests the objects that pays for it. So now the cost is distributed across all the individuals that are fetching these from you, as opposed to you bearing the burden. So that's a really important, I think, aspect of making modules available publicly is, yes, you pay the cost of storing it, but that's 2.5 cents, less than 2.5 cents per gigabyte. So that's not too bad. However, it's the variable cost of data transfer that can really be concerning, and this completely eliminates that from the equation. In order to access objects on a bucket that has this feature enabled, you have to specify explicitly that you are willing to bear the cost. Again, LambdaSharp does that automatically when it copies artifacts from one bucket to another, so that it is, again, the requester who is responsible. Data transfer costs, again, for an individual are fairly small. They get only large in aggregate, which is why not having that cost being on the person who provides the module is such, I think, a key feature. The next thing we do is now we have our bucket. The next thing is we need a deployment tier. That's the concept that LambdaSharp uses for publishing to destination, the deployment tier. And when we create it, we know that we're not going to be running any code on it, so we can disable the core services. We don't need Kinesis Firehose for monitoring, because we're just going to use it as a place for publishing to. And the next step here, if you've run it in the past, you would always hit enter, and it would have created a blank bucket for you if you left it blank. However, in this case, we actually want to associate this deployment tier with this bucket. The only thing you have to make sure is that you create both in the same region. It is possible that you would run the command at 2 different times in different regions. That's not healthy. Bad things happen. Don't do that. Make sure that your bucket and your deployment tier fit the same region. And then he creates it. It's a fairly quick process, takes only like 13 seconds. And now you have a deployment tier that is tied to a public bucket, and you're ready to go to town. So, and in this case, publishing would be exactly the same you've done before. You would target as your deployment tier that public bucket. So let's just see what it looks like. We open here. So we have our module. We built it. So I have already multiple tiers that are available. So I created a build tier. We'll use it at any moment. And I have a public tier, which is the one I was just mentioning. And I think it's DB public. So if I say util list modules, and I go to DB public, which is the bucket. This is the S3 bucket associated with my public tier. There's nothing in it. It's an empty bucket. Great. So let's publish something to it. The module we have, and we say the tier we want to publish to is this guy. This should be fairly fast. We built it earlier, so there's nothing to recompile. The artifacts are effectively already what they were meant to be. And it goes ahead and publishes it. And as you can see, this module has a more complicated name. So this is the namespace. Whoops, Acme is the namespace. And then Bitcoin price analyzer is the name of the module. So it got published. And if I were to go now to S3 and refresh this, we will see, it's a little bit bigger. We have Steve B public. That's the name of my bucket. And if I go into it, we have Acme, that's the namespace. And then we have Bitcoin.price analyzer, that's the module name. 1.0-dev, that's the default version when nothing is specified. And .artifacts contains the artifacts that were published by this command. So just as we intended. So you can now, from your account, if you're running this, you could just run this command again. And you would be able to list the, whoops, you would have to say include pre-release because with the dash at the end, it's not considered a stable release and these modules are not listed. Thankfully, it reminds me, and it shows us that there is now an Acme Bitcoin price analyzer 1.0-dev that is available as a module on this bucket. So this is now globally available to anyone who wanted to deploy it. And they could just, from wherever they are, if they have a deployment tier set up, they would just say /deploy and then provide the name, the complete name, and it would find it in my bucket, import it into that deployment bucket, and then instantiate the CloudFormation stack around it, all implicitly. There's an additional step that happened here, and I'll go into that in a moment. Okay, wonderful. So let's go back to our site. So now what you may have noticed is this just went straight to my public bucket. That may not be what I want to do, especially if I have a constellation of modules that are meant to work together. Specifically, I don't want to publish module A and then module B fails to build and doesn't publish, and now I have this kind of inconsistent state. So for that, you can use a form of stage publishing, which is exactly what we use at MindTouch for our CI/CD pipeline. And that uses a couple of additional concepts. So here's how it works in practice. The idea is, instead of publishing directly to your destination bucket that you have where you know you want things to end up with, you actually publish it to a build bucket. So this one will just contain the build artifacts of the modules and the dependencies and nothing else. If it passes validation, which means, for example, if there were multiple modules needed to be built, all of them built successfully, you can also now instantiate them, create sample CloudFormation stacks from them and validate those. If you're happy with the outcome, you can now import them, which is another mode for the publish command to work, which copies them from the build bucket into your destination bucket, which might be the public bucket. So this gives you a two-step process that gives you much more control of what becomes visible. So we use it for the obvious reason that we don't want to deploy something that might have gotten built So we don't want a new version to become visible, which might then be picked up, unless we are satisfied that it meets our quality assurance requirements. So this two-stage is enabled by this process. So it's very similar to before. However, build buckets, we have a little bit of a convenience feature here. And the build bucket needs to stick around long enough for you to do the validation and copy them into your target, your final destination bucket. The deployment here does not. So you can create a deployment here, you do all your builds, you can then destroy the deployment here. It will do nothing to the bucket since the bucket was explicitly attached, which means the deployment here did not have ownership of it. And you can now import the artifacts that are in this build bucket from anywhere the build bucket is accessible from. Another account would require additional roles to be set. However, in your account, you should have access to it. Now, for what we did on the build bucket side, we created this concept of an expiring bucket. It's a little bit more complex than the public bucket. So fundamentally, it's private, as you would expect it to be. But it also comes with a lifecycle policy on the bucket that checks if any assets are older than 3 days, they get deleted automatically in the background, no code to run. It's just taken care of. And then there's also a timer that gets deployed that checks every 6 hours if this bucket is empty. So if you create it and for some reason your build failed immediately and you never published anything, then after 6 hours, it will be seen as being empty and it will self-delete. That's why we call them expiring buckets. The stack will delete itself and just go away. The bucket will go and everything. If you did build something to it, it will stick around for up to 3 days, which is the lifecycle policy. At that point, the lifecycle will take care of it, delete it, and again, the timer will kick in, which runs every 6 hours, see that the bucket is empty, and automatically delete the stack. So these are kind of fire and forget CloudFormation stacks that have a bucket that are perfect for staging intermediary builds, and you don't have to keep track of them. They will just go away whenever they're no longer needed. If you want something more permanent, don't use an expiring bucket in your build. You can just publish to a bucket that you created that doesn't have this behavior. We found it to be very useful so that we can isolate our dependencies effectively. So the next thing here, I do the same thing I did earlier. I create a new build tier. This was the Steve B build tier that you saw earlier when I listed my tiers that I have on my account right now. And instead of going to interactive mode, I just provided everything over the command line. Again, this is meant to be used more in a CI/CD kind of setting. And so we provide the Steve B expiring bucket name, and it just initializes a stack. Took 8 seconds, very fast. So this is needed in order for the LambdaSharp tool to be able to publish into the build bucket. It needs a deployment tier. That is simply its entry point that it requires in order to be able to publish. Great. So now comes the tricky part. If we go back to here, so we have, as you notice, when we published our Acme module, it published it automatically into the Steve B public subfolder because the bucket is named Steve B public. However, if we have a different target bucket, these paths, once they're created, they can't change. So we need to inform the build tool that we actually mean to publish to a different destination. So let's go back up here. So going back to the command line, and that can be done again down here. I'll make this a little bit bigger. So where do we have publish? And now I can say module. And I can specify an origin that is different from the automatically inherited origin, which would be the target bucket that we're going to be publishing to. That's what it is 99% of the time when you do development and so on. Works great. But if you know you're going to stage it, you actually need to give it the name of where the final version should reside. Now, if you're careful and you always specify explicitly which buckets to use, technically that bucket doesn't have to exist. And that's actually something that we do because that way there's nothing, nothing happens by accident. Everything has to be explicitly provided. So it's certainly possible to, for example, the demo bucket is not one that I own. And now it is homed in on demo. And if I go back here and refresh. 5. We now published the same artifacts we had earlier, but they are now in a different, they're considered to be part of a different origin. So this allows us to effectively stage things that are meant to go somewhere else on a different origin into a bucket that doesn't initially match the name. And that's the process by which that is achieved. It's the module origin, you append that to the publish step, and now it takes that as its origin, and you can see how it's then reflected at the bottom as well. So rather than to do it, so that showed you how to do it on an arbitrary place. But let me now show you how to do it actually with the build, which is really how it's meant to be used. So let me just, again, make sure that tier list. Okay, oops. Yeah, list is not going to work. Okay. So I have this other, so what I want to do now is use the same process, but first publish into my build bucket, which is an expiring bucket, and then import it into my public bucket once I'm satisfied with my quality assurance. I've instantiated it, I've tested it. I can just reference that location like everywhere else, and it will resolve it from that source. So I can do all the validation. So we're gonna say, instead of publishing to, so we're gonna publish to build, and we are gonna, this is gonna be public. Okay, so did the exact same thing, except it's in the other spot now. My God, can you just guys? What's the do not disturb mode? Okay, refresh. So we can see now we are in the build bucket, but it is published for Steve B public. And just to make sure that we do this all right, let me just nuke everything in my public bucket. Permanently delete. Goodbye. Okay, close. Wonderful. But that's why it's I was expecting the location to be here for refresh, but actually if I zoom in one more level, it changes and went over there. That's why I didn't see it. All right, good. So we have refresh. Great. So now we want to publish what we have in the staging bucket into our bucket for that's public, or production bucket, whichever it might be, right? It's this two-phase kind of. If we just try to publish it, so we go from, so we want to go to, okay, that's public. So I want to go to public from origin. This is where we're taking it from Steve B build. That's my build bucket. Let me just make sure I got this right. From origin Steve B build, yep, and then the name of the thing I just published. So the intent here is to say, I want to publish into my deployment tier, which is the public tier now, this module. Now, when you do that, when you bring in dependencies from other sources, it only brings in the module itself. And so in this case, this operation should fail. And it did, because our module has a dependency, in this case, the bitcoin.event, which is the thing that triggers, and actually bitcoin.event itself, and we saw it earlier here, when has its own dependency on bitcoin.topic. That's the actual Lambda function that triggers once per minute and goes and fetches from the API the price and then publishes on the topic. Bitcoin event takes a dependency on that module and then subscribes to that topic and publishes as a event bridge event, CloudWatch event. But we wanted to hook it up to the CloudWatch event, which is what we're using here. So that's why we content event, but they actually build on each other. So what we need to do, and this is just to be explicit. Remember, one of the intentions here is to make sure we know exactly what it is we're making available in potentially our production environment. So nothing should get pulled in without consent. The way the tool detected that we were missing something is by looking at our destination bucket and seeing, was it able to resolve this dependency just by looking at the destination? And since I just deleted everything, the answer was no. So what we need to do is explicitly import them, which was kind of what I was showing up here. So it follows the same syntax, except in this case, we don't need to say from origin, because in this case, it is actually published on the right bucket. There is a serverless bucket, and it's Bitcoin dot, that's it. And it looks like that event version 1.0 at serverless pattern. Okay. So this will find the dependency on the serverless patterns S3 bucket, which is public, and then do an S3 copy command. So this no bits are ever downloaded to the machine here. It's all done from S3 bucket to S3 bucket. It copied it and its dependencies. And then if I go here, and now we can see that our public bucket now has these dependencies brought in. These were imported explicitly to make sure that we know what we have. Oops. Okay, and so now if I go back and I try to publish from our build bucket into our public bucket now, it will find those dependencies because we have made them available now. Ooh. Or not. Oh yeah. Force refresh. That is, it cached the notion that it didn't see it earlier. Ran it into this bug. So force refresh just tells it like, you know what, go list the content of that bucket again. And make sure, it keeps, when it caches information about content of buckets, because they take quite a bit of time when you have a lot of them during the build phase, it keeps it for 10 minutes. So after 10 minutes, it forgets and it will list it again. But in order to bypass that 10-minute period, you say force refresh. Great. So this time it actually did go back, relisted the contents, and it imported the artifacts from our public bucket, from our build bucket directly into our public bucket. So if I refresh here, we are good to go. Okie dokie. And let's see. So that's what. So just to show you how all the pieces kind of work together, this actually went faster than I had hoped. Let's just create a new deployment tier. Give it a tier name. What should we call it? Oh yeah, well, publishing. Maybe that's not on. Publishing and share might be a little bit longer of a name. Then CloudFormation can complain it has only 64 characters for a lot of resources, but I'll just call it demo. I don't think I have a demo tier yet. So this is just initializing a new tier. We're doing a quick start so that there's no kinesis pipeline and anything of that sort. We don't care about monitoring. So that should only take about 30 seconds. The longest part being it's creating now a new deployment bucket here. So if I go here, we should see the demo bucket being created. Demo, here we go. So that bucket contains nothing, as you would expect, since it's a new bucket. Great, got created, takes about 30 seconds. And now we can just say, actually, let me change folders. So we're nowhere near where the code actually exists. Lash deploy, and what do we call our little baby? It was called, now of course, I feel like I'm tempting the demo gods a little bit because I actually did not try this out in my, rehearsed it. And this was steve-b-public. So you would be able to run the same command. Oh, and then I need to say where I want to put it to. And we just call this demo. Ah, no, could not find. That should teach me to do it without. I wonder if it's the pre. Yes. Modules. It is. Okay. Did I mistype something? Bitcoin price analyzer, Acme, TS demo. Maybe it doesn't like the pre-release numbers, so not a problem. I'll just let me add a version number here, so make it a stable release. Not sure why it doesn't like pre-release, but okay. So we say lash publish. We want to publish this to our directly to the public tier. And I think that's all I need since we're already going public. We don't need to set up the origin. Oh, no, then maybe I need to go back into my folder. Oh, yeah. So there's a big differentiation between what's called when there's an extension, which is called a pre-release. It's very lax. When you have a fixed number, in this case, it detected that I had some non-committed Git changes, which were like, you shouldn't publish stable version numbers, which are meant to be immutable when you still have uncommitted changes. Fortunately, pretty much everything can be forced, just like with Git, force push, don't do it. Just don't do force publish either. And so now if we go to our, but that said, if the need is there, you certainly can do it. If I go to my public bucket, I should now see two versions published, that version, the 1.0 version. Okay, so let's try this again. And if this doesn't work, then it's definitely a typo. There we go. And as you can see, it's importing the dependencies that it found. It's also imported Bitcoin price analyzer because we gave it, I know I'm in the same folder, but you can see there was no build, there was no publishing and so on. Instead, it defaulted to just importing all the dependencies that were needed. There's a feature called build policy where you can more narrowly define what it is allowed to resolve. It's not unlike, I believe, the global.json file in the .NET compiler. And that allows you, again, to give more control over which versions of dependencies are you willing to resolve to. Because it is often the case that, you, again, in a production environment, you just want to resolve to wildcards. You want to approve every single dependency, make sure that it meets your requirements, and not just pick up things up out of thin air. That would be extremely unfortunate, especially after QA has validated everything from a staging bucket. And then when you import it, suddenly it brings in dependencies that were actually not part of the validation. That would be really bad. So there's a concept called build policy. I didn't go into it today. I felt it was maybe a little bit too much. We already covered a lot of ground. But there is a page on LambdaSharp.net called, if you look under Getting Started, called CI/CD, and it talks about build policies and how they can be used. Now, the first step that the tool did was to import all the dependencies, which were the topic, which is again the Lambda function that reads every minute from an API the Bitcoin price and publishes it to a topic. It exposes the topic as a shared resource, a public resource, as part of the stack. The event module said that it has a dependency on that other module and imported the topic, subscribed to it, and then when it gets notified, it publishes it to EventBridge. EventBridge, or at least SNS, doesn't allow directly publishing to EventBridge yet. Maybe that's something to add in the future. For now, we need a Lambda function to provide that glue. So what we see being created right now is the first step of the stack, which is the Bitcoin topic. So this is the Lambda function that actually does the creation. So I'll let this run. It's going to create the event, and it's going to create then the Acme stack afterwards. And then we can take a look. But just to reiterate a little bit, the benefits of this design was, I am a strong believer that you should use the artifacts in production that you validated. You shouldn't rebuild them and republish them. You never know if the second build is exactly identical to the first build. So by virtue of publishing into a build bucket, be it expiring or not, you can validate exactly what you built. And when you're happy with it, then have it imported into the bucket that you actually use for updating your production environment. It's publish once, deploy many times. It's the safest way to do it. The other thing that is possible is because the dependencies are imported into your bucket, even if I went, let's say you you deployed the application we just built, a little Acme, which is just listening to the event, and it's just logging it to CloudWatch logs. But if I were to delete my bucket, or I were to make it private, either way, you have a copy of this artifact in your bucket. So if you have to redeploy or do something, you are not dead in the water. You might not be able to ever fetch updates to it because you don't have access to the upstream bucket anymore. But by virtue of having a copy of everything that was needed for deployment, you're isolated from any of those changes. Furthermore, because you can publish into your deployment bucket using specifying your own origin, if, for example, the upstream module that you were using, maybe it's abandoned and there's an issue with it. It was open source, but it's abandoned and the author is not updating anymore. You can actually publish it into your deployment bucket, a fix that then your modules that you deploy from there, they will pick up your shadowed copy, if you will. You can shadow the original, create your own, and that then has a slightly different behavior that basically addresses whatever issue there may have been. So you have independence from a package becoming unavailable, and you have also independence, if it is a public package like an open source module, from being able to maintain and rev it independently. And even if this is a dependency of a nested dependency, it always resolves against your bucket. So there might be a module in between you don't have access to, but it used that as a dependency. It will pick it up. So again, it gives you control over what gets deployed, which is absolutely essential for production environments. And then lastly, the two last things are the last bullet I already covered in great detail, which is anybody consuming module that you have published, they're picking up the tab for the transfers. So if there's 1,000 people that fetch your modules, they have thousands of the cost as opposed to you getting the cost of all 1,000 transfers. I think that's really important for public buckets. And then because by virtue of using these staging buckets, the build buckets, which again, if you know that your pipeline is time bound, you can use an expiring bucket for it. You can make sure that everything looks good before you promote it into your destination bucket. Right? That's just an import command. And again, it will not import it if it's missing any dependencies and things of that sort. So this two-stage process gives you, again, control and confidence that what you make available into your production environment actually meets the requirements. So hopefully I've spoken long enough. This should be published. Wonderful, it is. So this deployed 3 stacks. The first one is the topic that does the listening with its Lambda function. The second one, this one is triggered by a rule that triggers once per minute. The next one is our Bitcoin event, which is a Lambda function that is actually doing a subscription to the topic that was created by the first stack. And finally, similar to what the previous one was, we said that we had a dependency on event, which means we know that it's going to be available. And then we said that we wanted to listen to the source, which is the name of the source that this module publishes on. So if I go back into here, I'll hit refresh. Bitcoin demo, Acme Bitcoin Analysis, so that we just created this, this whole stack. This is completely independent from anything else we did. Oh, oddly enough, it doesn't pick it up when it's misspelled. Okay, and here were the resources. So I can go to the log group, and if all went well, we should have a log stream here. We do, wonderful. And the log stream has all kinds of invocations, and we can see this is the log statement. I actually didn't show the code I realized in the analyzer. It's an incredibly simple implementation. It gets the event and it just serializes it back out into the log. So the idea being, if you wanted to do Bitcoin price analysis, this is where you would do your bidding and then decide to buy or not to buy, similar to the Bitcoin hot or not app I demoed previously. But this is the payload we received. And so everything has been wired up, all has been deployed. In this case, it pulled in resource module and artifacts from my Steve B public bucket, but it also pulled them in from the serverless patterns bucket, which is a completely different thing. mean, I own both, but it's irrelevant. They're both public. So that kind of wraps it up in a nutshell. I hope you find it interesting. The code for this will be available later today in the publishing and sharing. And that's a wrap. So thank you for listening.